Hello, this is Professor Ma, and this is the sections on sign chart, specifically sign charts for factorable formulas. And first, what's a sign chart? So here's an example of a sign chart. We have a formula x minus 1, and this is a sign chart for the formula x minus 1. And the most important points in this sign chart is where f is equal to 0. So that's a root. At x equal to 1, plugging 1, I get 0. And then the plus sign means anywhere over here on the right-hand side, you're plugging a formula x equal to 2. And if you put in the formula f, you get a positive number. We don't really care about what numbers comes out. It's just what's the sign of the output. And here's a negative part into putting x equal to 0. Or minus 1, for instance, if you put x equal to minus 1, then you're going to get a negative outcome. So in a sense, this sign chart is a one-dimensional information about the function f as much as possible. Okay, and later on we'll extend this information into a stretching to two-dimensional graphs. Therefore, the sign chart is a very important tool that we use in analyzing, in particular, when we talk about the graphs of factorable formulas. So it's important for any functions f, formula f, it's important to find out when is a positive, when it's 0, when it's a negative. Okay, and that's essentially what sign chart does. And before we do that, let's recall one of the things about factorings in the factorable formulas. One convenient thing to do is check the sign of the outputs. If I have a formula that's factored completely into parentheses of binomials, then it's easy to find out what the sign of the output is. For instance, if I want to find out what's the sign of the output, if I'm putting minus 3/2 into for x, and then I calculate what the sign is. I don't have to calculate what the number is because the front is a negative sign, and both of them are negative signs. So therefore, I know the output is a positive numbers. Okay, and here is what happens if I was putting minus 1/2, so I get a positive and a negative sign multiply. Therefore, the output is negative. And this also works also for fractional formula. If the fractional formula can be factored into parentheses binomials again into two terms, and we can use this trick to find out what the output of the sign of the output is. So if I'm putting minus 3/2 into for x, then I will have a minus sign. Putting minus 3/2 into x plus 1, I have a minus sign. Putting minus 3/2 into 2, I get a plus sign. And so get minus sign for x minus 1 also. So altogether, then I calculate the sign that's going to be a negative sign, and which means less than 0. And similarly, if I'm putting minus 1/2, I will get these sets of signs for each parentheses. Then I tabulate the signs that's going to be positive because of 2 negative signs. Okay. So with these techniques, we can make sign charts for formulas. Okay. Again, what the sign chart is, okay, it tells you the sign of the output. And in this particular problem, the boundary point, the separation points with 0. The 0 doesn't have the sign. It's not positive nor negative. It's neutral. So those are the border points. Okay. And we're going to first do one way do the sign chart by sampling points, and then we do another way, which is for factorable formula, which is a lot faster. Okay, And so here is how we do construct sign chart by sampling. Okay, and one of the fact we use is the very important is that the formula we have does not change if these are zeros, x, if this is f equal to 0, f equal to 0 at different locations. Okay, we assume everything within here of the same sign. That is in between two zeros. We assume all the signs in between are the same. Okay, this fact is true for all the formulas, factorable formulas that we are going to look at. So we assume these. So how from there, how do we construct the sign chart of the second degree formulas? So let's bring back what we did do over here. The first step, you solve for 0. The first step, you find what the point 0 is. Okay, so factor and the solve for 0. Then we mark them on the line. We're going to make a one-dimensional graph for this formula. So these are the what the function, what the polynomials, what the expression is 0. Okay, and how about the other places? Well, the other place you want to find out whether they are plus or minus. We sample points. So what do you mean by sample points? What we mean by sample points, we choose a number and test it. Okay. For instance, here we choose -2, then we test what the sign is going to be, and that's going to be plus. Plugging -2 into x. Okay, you're going to get a minus negative number times the negative number. This is negative, this is negative. So multiplying then give positive. And if I test 0 in the middle segments and putting 0 in for x, and then I will get -4 times +1. I get negative sign. I don't really care what the number outcome is, but rather I care what the sign is. So putting 0, I will get a negative number. Similarly, if you check, you're putting 5 in, you will get a positive number times a positive number. So you get a positive number. So therefore, this entire segment's to the right-hand side, positive side. So this is the sign chart for x² - 3x - 4. Okay. As we said before, it works also for fractional formulas or rational formulas. So in this case, I will need all the roots from not only from the top, but also the zeros from the bottom, because those are the breaking points that when I plug in the number 3, -2 or 1, try to plug in the formula, I will get either zeros or it doesn't make sense. In other words, plugging in these numbers, we don't get a positive sign or negative sign out of it. So they don't determine the outcome of these inputs does not have signs. What we are interested in is where there are signs, positive, negative. Therefore, we have to mark all 3 of these points down. Okay. In between these points, the output, they will take on the same sign. And how can I tell which segments will produce which sign? Well, again, by sampling. So I won't bore you on the sampling, but I sample these points. And you say, wait a minute, why did I choose -3? Can I use -4? Sure. Okay, that's what we mean by sampling here. You get to choose a point in that interval and test it. Okay, and I choose 0, and we'll get the following sign. Therefore, this is the sign chart for this fractional formula. Okay, now. Now we come to the important things for this class is that making the sign chart of factorable formulas. And we will do, first, let's define what we mean by factorable formula. Factorable formula are factorable polynomials and factorable fractional formulas. Now, what's a factorable polynomial? A factorable polynomial is a polynomial that can be broken down into product of linear terms, okay? And this AI, if you say, what's this AI doing? What we mean by that is AN, and the AN over there is the, if I factor that number out, then I can factor the rest of the polynomial into this form, which starts out with x times x times x. So therefore, when I multiply the first terms out, I get a and x. For instance, this is a factorable polynomial. Here, we take out the common factor, 2x cubed, and the leftover over here is x minus 4 squared, x squared minus 4 squared, and the x squared minus 4 x plus 1 minus 2. So therefore, this factor completely, notice the 2 is on the front. That's what we mean by this a and out here. And that, what I actually have is x minus 0, x minus 0, x minus 0 3 times, x plus 2 twice, and x minus 2 twice. Okay. It's 7 powers. Power x to the 7th power. Therefore, there are 7 parentheses. Okay, so we can deal with that in that manner. Okay. And from this form, we can extract the zeros, or what numbers plugging in zeros. Okay, so these are factorable. If the polynomial is factorable, that I can easily recognize where the roots are, the zeros. And in this case, we have the root 0. Okay, from plus 2, I get minus 2. From minus 2, I get plus 2. Okay. And here's the most important part about the roots is how many times it shows up. X minus 2 squared means there are 2 parentheses of x minus 2. Therefore, the repetitions of the root 2 twice. Okay, so that power it comes with, we call that the order of the root. Okay, so 0 has order 3. It came from power x to the 3rd power. Okay, the root x minus x plus 2, the root x equal to minus 2 has power, came on power 2. So it has order 2. Similarly, the root for positive has power 2, order 2. Okay. Now, what we are really interested in is whether this order or this power of the roots came with the root is even number or odd numbers. And the reason for that is we're going to raise these roots somehow to that power, and the even power turn everything to positive. But the odd powers will retain the sign of the base. So negative number to an odd power is negative. Okay. And that's where it's the importance of the power or the order, that is, whether it's even or odd. Okay. So we don't keep track of that. So for example, okay, x0 is an odd order root, odd power. Okay, power is 3. Even order root, x minus 2, both are even order. Okay. And here is a theorem tells you how to make a sign chart really fast. Once you can factor and identify the the roots in their orders. Okay, so we'll just do one over here. Okay. First, let's make the sign chart of these. So the roots are 0, from here -3, from here +3. Okay. And let's look at the order, which one has odd order, which one come from odd powers, which show up odd numbers of times, and which one show up even number of times. Okay, 0, x equals 0 show up 3 times, x equal to 3 show up 1 times. Okay, so therefore the root 0 and 3 are odd power. Okay, odd orders, they have odd power. But the root for the root -3 comes with the power 2, so that has an even order. It has even order. So we mark the roots down, and then we also mark down whether the orders are or even. Okay. Then this is what the theorem says. Let's go back to the theorem says. The signs are the same on both sides of an even order root. The signs are different on 2 sides of an odd order root. Okay. And we have these roots identified with the orders. So therefore, here we go. Let's test 1 point. Let's look at test number 4. And you're putting the number 4 into this, and you have positive number times positive numbers, and 4 minus 3 is positive. Therefore, everything's positive. Therefore, this we get a positive, and therefore these segments to the right of the number 3, they all positive. They all the same. Now, how about on the other side of the number 3? Well, that's where the theorem says, if the order is odd, the signs on the other side must be different from positive. So it must be negative. In other words, when it crosses the odd order root, it changes sign. When we crosses, now come to x equal to 0, when we cross x equal to 0, again, it's odd order root. Therefore, this changes signs. Okay, we change because it's odd. Change sign, change what? Change sign. Okay, because they are odd. Now here come the even roots, and the even root says when you cross even root, the sign doesn't change. They're the same on both sides of even order. So therefore, this is the sign chart. Okay. And that's what the theorem tells you. The theorem is that we just said. Signs on both sides of even order rule the same. Signs are different of odd order rules. And this is an easy way for us to identify, once we know one position, whether it's even or odd, then I can propagate and deduce what's next segment, and so on by the order of the roots. Okay. So this is how we do to find the draw the one-dimensional graph, if you like, or sign chart of a formula, in particular factorable formula. Okay. This works also for fractions, fractional formulas. So first, factor everything. By factorable, we mean that the fraction means the top can be factored completely, the bottom can be factored completely. So from looking at these, I can tell the roots is at 0 for x, and 2 minus x, the roots x equal to 2, and x minus 1 give you x equal to 1. Therefore, this one 0 is even order. One has even order, but the two has odd order. Okay, so we draw the line. Okay. And also we test x at 3. Okay. Then I get a minus sign. Okay, then use the rules again when we cross odd. When we cross the odd orders, it change because odd orders is a plus. When you cross the number 1 on the other side, on the left hand side of number 1 is even order, so it doesn't change. So it stays plus. Then you cross the other 0, it's still plus because these are evens, both are even. Okay, it's unchanged and unchanged. So this is the sign chart. Okay, and so and for the homework, do the most. Okay, just drawing picture, draw all these one-dimensional pictures for all these factorable formula. And this is one of the most important sections for the course for next chapter also. Okay, and that's it. Okay, have a good day. Bye-bye. Stop recording. Yeah.